Hello and welcome to Programming Rush. Today in this video we are going to find the greatest common divisor of two numbers in C++ programming. So this is an efficient algorithm and it can calculate the GCD very fast. But for that we need to see the mathematics behind this. First let us take an example of number A as 2. Wait, let me comment it. A equals to 2 and B equals to 3. Now I will have a function which will return a type of int value, and it will take two variables, int A and int B. Now when I call this GCD function, it will pass 2 and 3. I will call like this. The function will first check that if A is equals to 0 or not. If 0, then it's going to return the B. Otherwise it is going to recursively call this GCD function again. So it will call this GCD function and pass a different value, this time for the A. It will pass B mod A. What is the B mod A here? 3 comma 2. 3 mod 2, that is 1, comma the number A, means number A here, A, that is 2. Now again it will run the program, and again the GCD function will check if A is 0 or not. If it is 0, then it will going to return this B value, but here it is the A is not equals to 1. So the next, again this function will be called GCD function, and in GCD now it will pass 2 mod 1, which is equals to 0, and the number A here, that is 1. Previously we had 2 and 3. This was A equals to 2 and B equals to 3. Now then we passed B mod A, that was equals to 3 mod 2, which was equals to 1, and here we passed the A. Now again this was checked, and if false, this was called GCD A. GCD B mod A, which is equals to 2 mod 1, and we know when any number divided by 1, it leaves the remainder 0. So here we got the remainder 0, and here we are going to pass the A. Here we have got here A, which is equals to 1, so we are going to pass in the place of B A. So we are just swiping the A to B, and in the place of A we are passing B mod A. And now in the next time it is checking A equals to 0 or not, and yes, it is true, so the B is returned, and the value of B is equals to 1. So the greatest common divisor of A and B is 1. Now let us take another example of 12 and 15. So here it is 12, it is 15. Now this is checked, this is false. Now B mod A, 15 mod 12. Now the remainder is 3. We know here the remainder is 3, so 3 is passed here and A is 12 now. Now again this is checked, we have got here 3, this is not equals to 0, so this is called, here we have got A is equals to 3, so here it will be 3, and in the place of B we are going to pass 12, which is 12 is divisible by 3, we know, so the remainder leaves here 0, and in the place of A now we have got 3. Again, this is checked that if a is 0 or not. Here we have got now a is 0, so we are going to return b, and the value of b in this case is 3. And yes, this is true, the greatest common divisor of 12 and 15 is 3. Now, how this program is efficient? As you can see that for calculating the greatest common divisor of 12 and 15, we just took only 3 steps to calculate it. But in natively, we have to create a for loop and then check for each value that if a or b is divisible or not by the same number, and if it is divisible, we are going to increment that value. Also, if we want to save our time, we can decrease the value from I equals to min of a or b, minimum of a and b, and then we are going to decrement the I. But that does not help, because if the GCD is 1, then we have to loop throughout this algorithm. But in this case, we are just recursively calling the GCD function and passing the b mod a value. So this helps us a lot in saving the CPU and memory. Now we are going to implement it. Now we are going to check if a is equals 0. If true, we are going to return the b, and this is also the terminating function, because we need to terminate this recursive call. And if not, then return GCD of b mod a comma a, and one time this a will be 0 for all the cases for any number. Here we have passed here a equals to 0, return b, otherwise return g mod a equals 0. And here we have our code for taking two numbers in code. Now we are going to calculate this value. We will write here the GCD of two numbers is, that is GCD function itself, comma b, and well, let me zoom out, and here it is the function, it is the code. This simple function saves us a lot of time. And now let us run this. Let's see if it works or not. So enter the first number. So let us take here 2 and the second number as 3. The GCD of the two numbers is 1, which is correct. Now let us run the code again. Yeah, so enter the first number. Let me give a bigger number now, 80, and here I'm going to write 40. The answer should be 40. Yeah, the GCD is 40. Now let us write a large number here. I'm just going to write a random number. Let's see if it works or not. I'm going to make it even, otherwise it won't. The GCD of two numbers is 1, so I don't know. I need to find a good example here. Let us write here 4096 and next number as 1536. Yeah, the GCD of the two numbers is 512. Yeah, it is correct. I have calculated this value. So yes, our code is now working. This GCD function is a recursive. We are recursively calling this GCD function. If a is 0, it returns b. Otherwise, it passes the b mod a value. And every time we are calling this, we are reducing our number. Means this number is always lesser than this a. How large may be the b, this value will always be lesser than a. And when we again call this function, this value again reduce drastically. So this code is very efficient for calculating the greatest common divisor. In place of int, we can also use the long for very large numbers, something like 10 to the power 12, 10 to the power 18, but this will be good for 10 to the power 9 numbers. So thank you for seeing this video. If you like it, please like the video. If you need this code is available in the description below. Please check it. Subscribe the Programming Rush channel. Thank you. See you in the next video.